So today we are going to be looking at finding the determinant of a 3 by 3 matrix and thereby also finding the inverse of a 3 by 3 matrix. So there are two methods generally of finding the determinant of a 3 by 3 matrix. Just like a 2 by 2 matrix, this has a little bit of work. So there is one method called the cofactor stroke the Laplace method, and this is a general formula. Of course, when you have matrix A having all those elements, so what you do is that you can choose any of the rows to help you get the determinant. You can choose the row 1, which is ABC, or choose the row DEF, or choose the row GHI. So in case you choose the first row, you are going to assign these signs here, plus, minus, plus. In case you decide to choose the second row, you're going to use the signs negative, plus, and negative. Okay. In case you choose the third row, you're going to use plus, minus, plus. So in our case here, we are using the first row. So what do? You take A multiplied by the minus of A. Remember the minus, we did minus in our 2 by 2 matrix. So take A, cross the row and the column where A is, and there is the submatrix that you get EFHI. So multiply A by that submatrix. Then there is a plus sign. Remember, this is a plus sign here. So you're supposed to take the plus sign just before A. So it's plus A multiplied by the minor of A. And of course, because you cannot have it being a matrix, you have to get the what? The determinant of this EFHI. So you need to get the determinant of this. Then minus B. Okay. So remember, minus B is this minus right here. So minus B, so remember you're using the first row, minus B, then you get the minus of B, which is DFGI. Then of course, eventually you will have to get the determinant of this submatrix here. Then you go to the last one, which is plus, so plus C, then the minus of C. So of course, then you'll have to get now the determinant of DEGH. So now, assuming this is a matrix A, so let's do that here now practically and see, so that you can see how it's done. So let's say we're using the very first row. I said you can use any of the rows, only to remember that you put the plus, minus, plus if it's the first row. Okay. So the first thing you do is, now you're getting the determinant using the Laplace method or the cofactor method. So you're going to have 3 multiplied by the minus of 3. Remember the minus of 3? What do? You cancel the row where 3 is and the column. So the result, the submatrix you remain with is 1, 0, 2, negative 1. So you write it right there. Then minus, remember we are taking plus, minus, plus, because it's the first one. Then minus, plus, minus, plus, minus, plus. So this is what we are taking. So this is plus 3 definitely, but we don't need to write plus 3 because we already know if we don't have any sign there, it's obviously a plus. So plus 3 minus 1, and the next one is 1. So you come to, sorry, it's negative 1 actually. So you're at this point, so minus 1, then you get the let me just write it nicely. You get the minus of negative 1. So what do? You cancel this, you cancel that. So you remain with 2, 0, 1, negative 1. So that becomes the submatrix or the minor of negative 1. Then you go, now the last sign is plus. So plus 1 now. And again, you do the same thing. You get the minus of that one. So you cancel this and that. You remain with 2, 1, 1, 2. And you're done with that. Let me just remove this. It's not necessary here. Good. So the next thing I said, once you're done with that, is now getting the determinants of those matrices that have been formed. So 3 multiplied by the determinant of that submatrix there, which will of course be 1 times -1, which is -1, -1 times 2 times 0, which is 0. So this would be -1. Sorry for that, -1. Then minus and minus. Of course, when you multiply minus and minus, you get a plus. So now this will be a plus 1 into brackets 2 times -1. That becomes -2 minus 0. Okay, so that becomes -2. Then plus 1. The determinant of that matrix there is 2 times 2, which is 4. Then 4 minus 1. 4 minus 1, there again you get 3. So this becomes 3. And once you have it this way, now this will be -3 plus and minus, that becomes minus, so -2, then plus 3. So eventually here you get -2. So our determinant is -2. So if you did the same with the second row, you'd still have gotten the same answer. Okay, so for now you're just going to use that first row there. So that is now called the cofactor stroke Laplace method of finding a 3 by 3 determinant. Now I'm going to use the same matrix to get the determinant, now using another method. Okay, now this method is now called the Sarus rule stroke artistic stroke the shortcut method. So many people view it as a shortcut method. So what do you do if you have matrix there, A1, B1, C1, and so forth, so on? So you're going to multiply all the elements. So first, before you go to that, there you can see we are forming another matrix out of the original one. So this is the original matrix, but now we are forming another matrix right there. And how are we forming the other matrix? We are simply adding the first 2 columns on the other matrix, on the original matrix. So you take this column, add it here, take this second column, add it here. Okay, so now you're going to be forming another matrix to help you now calculate the determinant. So that's essentially what we are going to do. Then, as you can see, we are going to multiply the diagonals on starting with the main diagonal, which is marked with red, the first red. You multiply them, then you add the second diagonal marked again with red, plus, then you multiply the third diagonal marked with red, then minus the alternate diagonal. Now, you multiply the alternate diagonal, all of it marked with blue, plus the next alternate diagonal, plus the next alternate diagonal, as you can see right on our diagram there. So now, doing that now with our matrix here, as you can see. So we are going to do this practically now using the Sarus or the artistic or the shortcut method. Again, doing the same thing, we want to calculate the determinant and see whether we arrive at -2 with the same one. So what do you do? If this is your matrix, so I'm going to just write it here again. So I'll have just a moment. So I have 3, 3, -1, 1, 2, 1, 0, 1, 2, -1. Then what did we say? You add the first 2 columns. So the first column is here. So I'll add now 3, 2, 1, and add the second column, which is negative 1, 1, 2. So now we have formed another matrix from the original one. So let me just use a different color now. So now remember, we want to multiply. Okay, we want to do a multiplication of first the main diagonal, which is this one. So we are going to do mark the ones that we are going to multiply. That one is 1, another one there, and another one there. And then, of course, minus the alternate diagonal now. Again, I'll mark it with a different color for the sake of you to just see clearly. So 1, 2, and 3. So once you're done with that, we just need now to just now multiply and minus. So the first diagonal is 3 multiplied by 1 multiplied by negative 1, then plus the next one is negative 1 times 0 times 1, then plus the last one is 1 times 2 times 2. Okay, now all this you're supposed to minus. Now we go to the next one. I'll kindly use another pen. So this will now be, remember now we are on the other side, the brown one. So that will be now 1 times 1 times 1 for the first one. Then plus 2 times 0 times 3. Now the third one plus negative 1 times 2 times negative 1. You close the brackets. So now when we do now the very first one, that's 3 times 1 times negative 1. Okay, so 3 times 1 times negative 1, you get negative 3, plus negative 1 times 0 times 1, that's 0, plus 1 times 2, that's 4. So all this, you minus now the orange one, which is 1 times 1 times 1, which is 1, plus 2 times 0 times 3, that's 0, plus negative 1 times 2 times negative 1, that gives you a positive 2. So 2. Like that. So of course negative 3 plus 0 plus 4, that gives you 1, minus 1 plus 0 plus 2, you definitely get 3. So 1 minus 3, you get negative 2. So as you can see, we've gotten the same answer when we use the other method. So this was the shortcut method, and you can see it's quite short. It's a bit easy to actually work it out. So that's how you get what? That's how you get the determinant. Now let's now go straight to the inverse. How do we get the inverse of a 3 by 3 matrix? Now we have learned how to do a determinant, and remember the first step in getting the inverse of a 3 by 3 matrix is by first getting the determinant. Then step 2, like we saw in our 2 by 2 matrix, getting the inverse, it's the same process. So the first step is getting the determinant. The second step is getting the minus of every element, okay, in the matrix. So that's what we are going to do straight up. So the minor of 3, again you can see you cancel the column, the row and the column where 3 is. So what you remain with is actually 1, 0, 2, negative 1. You go to where negative 1 is, so the minor of negative 1, again you do this and that, so that you remain with 2, 0, 1, negative 1. That's what you remain with. Then you go to 1. Again, you do the same thing, you do this, you do that. So you're remaining with 2, 1, 1, 2. You do that. Then you go now to 2. Again, it's the same thing, the same drill. So you do this, you do that, and you're left with negative 1, 1, 2, negative 1. That way, you go to the next one. Again, so this and that. So you'll be remaining with 3, 1, 1, negative 1. And you're done. You go to the next one. Now you're at 0. Remember, you're looking for the minus of all the elements. So this and that. So you're left with 3, negative 1, 1, 2. Okay, then you go now to the last row there. The last row you having 1, so you cancel 1 like this. So you're left with negative 1, 1, 1, 0. Done. You go to the next one, which is now this and that. So you're left with 3, 1, then 2, 0. Then you go to the last one there, which is this. So you're left with 3, 3, negative 1, 2, 1. And finally, you're done. So having gotten that now, you can actually, there's a place we actually rubbed here. So by mistake. So this was supposed to be the first one, which is 3. So do this and that. You're left with 1, 0, and 2, negative 1. This is supposed to be negative actually. That way. 1, 0, 2, negative 1. Right. Okay. Alright. I think we are good to go there. So now the next thing that you actually need to do is getting the determinant of the resultant matrix that we found there. So what is the matrix of all those? That's what you actually need to just do. So the matrix of this will be 1 times, I'm just going to put it here, just right here. So again, I'll use a different color. And the matrix, the determinant of the first of this one here, it's that I'm looking for. 1 times negative 1, which is negative 1 minus 0, you get negative 1. The next one is 2 times negative 1, which is negative 2, negative 2 there. Then the next one, remember we're just looking at the determinant. 4, that is 2 times 2, 4, 4 minus 1, which is 3. Okay, so I don't know, I hope we got it right. We were supposed, for this one, we were supposed to cancel this and that you get, sorry, we're supposed to cancel, we were at negative 1, so we cancel this and that. So we're supposed to write 2, 1, 1, 2, yeah, which is fine. That's what we have there, so we are safe. So for the last one, we're supposed to have 2 times 2, which is 4, 4 minus 1, which is 3. So 3 right here. Then we now go to the second row there. So negative 1 times negative 1, that is 1. Then 1 minus 2, which is minus 1. Then you go to the next one. No, sorry. 1 minus, yeah, it's actually 1 minus 2, which is, I think, okay. Then you go to the next one, which is 3 times negative 1, which is negative 3. Negative 3 minus 1, which is negative 4. Then you go to the next one, which is 3 times 2, 6. 6 minus 1, which is 7. So that is 7. Then you go to the next one. The next one is now the third row. So Negative 1 times 0, that's 0, 0 minus 1, again that's minus 1. Then you go to the next one, which is 3 times 0, which is 0 minus 2, then that is minus 2. Then you go to the last one, which is 3 times 1, which is 3, 3 minus minus 2, which is 5. Okay, we got that right, that is 5. Okay, so these now are your minus for your matrix A. Okay, those are your minus for matrix A. So the next thing that you actually need to do is now get the cofactor. So this was step 2, remember? This was step 2. The first step was getting the determinant. Now we are in step 3. So I'm just going to do step 3 right here. So step 3 is actually multiplying this by the plus. Remember, now we are at the cofactor stage. So we want to get the cofactors. So how do you get the cofactors? Simply by multiplying the matrix with plus, minus, plus, minus, plus, minus, and plus, minus, plus. That's how you make our minor a cofactor. Okay, so of course you multiply the corresponding positions on the corresponding positions. Okay, so plus and minus 1, that still remains negative 1. Then minus and minus, that will be plus, so this will be just 2. Then plus and plus 3, that will still be 3. Then minus and minus, that will be just 1. Then plus and minus, that will be minus 4. Then this minus and this plus at 7, that will be minus 7. Then you go to plus and this minus will be minus, so minus 1. Then minus and this minus 2, it's a plus, you get 2. Then plus and plus definitely becomes plus, so that becomes 5. So that is your cofactor. Okay, that's your cofactor. Then after the cofactors, you now go to the next one. We've actually we actually done with the cofactors. Now the next part is now the cofactor transpose or the adjoint. Hoping you remember the cofactor transpose or the adjoint. Let me just write this that portion right here. So just put this part 3 cofactors. This would be negative 1, 2, 3, 1, negative 4, negative 7. I'm just writing what I have there. Then negative 1, 2, 5. So this is your cofactor. We have matrix there. So the next thing, which is step 4, let me just put it here. Step 4 now is getting the cofactor transpose, which is also called the adjoint. So getting the adjoint or the CT is simply changing the columns into rows or the rows into columns. So that will be easy. So you start with the first row, make it into a column. That will be negative 1, 2, and 3. Go to the next row, which is 1, negative 4, negative 7. Then go to the other one, which is negative 1, 2, and 5. And you're done with that. So now you have your CT or the adjoint. Once you have your CT, now you're actually going to the very last step. And the last step here is to multiply the CT. So this is the last step. Again, let me use a different color. So the last step, part 5, now we'll be multiplying the 1 over the determinant multiplied by the CT or the adjoint. I said CT and adjoint is the same. So sorry. So that's what you actually just need to do. So we already had our determinant, remember? So it's as simple as now multiplying. Remember, our determinant was negative a half, I mean negative 2. So now 1 over the determinant is 1 over negative 2. So you're going to have here 1 over negative 2 multiplied by our CT, and our CT is negative 1, 1, negative 1, then 2, negative 4, 2, 3, negative 7, 5. So that way. So now you can multiply that. You multiply with each and every element. So negative a half times negative 1, that is 0.5. Then negative a half times 1, that is now negative 0.5. Negative 0.5. Then negative a half times negative 1, again that's 0.5. I hope you're following. So 0.5. Then negative a half times a half, that becomes negative 1. So this is negative 1. Then negative a half times 4, which is times negative 4, because this is a negative 4. That becomes a half, now 2. That becomes 2. Then the other one is negative a half times 2. That becomes negative 1, actually. So negative 1. Now I go to the third row, negative a half times 3, which is negative 1.5. Then we go to the other one, which is negative a half times negative 7, which is 3.5. Then negative a half times 5, which is negative 2.5. So finally, this is your inverse, right? This is your inverse for our matrix right there.